All right, these are going to be the answers to the questions concerning the mixtures, the questions for mixture notes. So we're going to go through these, and hopefully, again, you already got them done. You already submitted them for credit. So now we're going to go through the right answers. You're probably going to want to make sure that you write down the right answers so that you have those for the future. All right, so when we get to the end of this chapter, that you have them to help you study for the test and be able to have for the open note test at the end. So first question says, what's the difference between a heterogeneous and a homogeneous mixture? Well, remember, heterogeneous are different throughout. From the top to the bottom, they're different. Remember the example we had in the notes was muddy water. Muddy water, we're going to have a lot of water at the top, right? Very little dirt. But when you go down to the bottom, there's lots of dirt and less water. So it's different from top to bottom, right? Versus homogeneous mixtures, those ones are the same from top to bottom. And the example in class was pop. A glass of Mountain Dew is the same top to bottom. Doesn't matter where you take a drink out of that 2-liter bottle of Mountain Dew, it's going to taste the same. Question number 2. Describe a procedure that can be used to separate a mixture consisting of salt water. So I want to get that salt out of that water. What can I do? I could just leave it out, let the water evaporate. As the water evaporates, the salt will stay behind. If I want to speed up the process, then I can add more energy to it and cause the water to boil, which will cause it to leave the mixture faster, and I can get the water off and I'll end up with salt behind. So I'm basically going to try and evaporate it in some way. Number 3, classify each of the following as a substance or a mixture. So the first one there, we got silver. Well, silver is the same throughout, so that's a substance. Next one, alphabet soup. That one's not the same throughout, so that's a mixture. A textbook, or any kind of book, that's not the same throughout. It's got papers, it's got ink, it's not the same, so that's a mixture. Table salt, that's made up of 2 elements together called sodium chloride. That is actually a substance. It's the same from top to bottom. Gold ring, that's the same all the way around the ring, so that's a substance. And the last one, chocolate milk. Oh, hey, we talked about white milk, but we didn't talk about chocolate milk. White milk, we said, was a colloid because I don't have to shake it. All right, that's going to stay like white milk. What about chocolate milk? When you pick up a chocolate milk at the school, what do we commonly do with it before you drink it? A lot of people, including myself, I'll pick it up and I shake it. Why do I shake it? Well, because when it's been sitting there, the chocolate settles to the bottom. So that chocolate in the milk makes it a suspension. The white milk that's present inside there, that's a colloid. So actually it's a suspension with the chocolate, it's a colloid because of the milk. So it's actually both at the same time. So that chocolate milk would then be a mixture. Question number 4, describe the difference between a pure substance and a mixture. Pure substance is the same throughout. A mixture is different throughout. Right? Number 5, describe 2 ways in which the various components of a mixture can be separated. There's a lot of different answers you can use on this one, so I'll give a few of them. One would be we could boil it. We can use the different ways in which they look. We talked about this in the notes, being able to separate them that way. We can use differences in density. When they melt down my truck someday, because I'm going to scrap it when it gets really old and doesn't run and it's all rusty, what they actually do when they melt it down, they use density. The heaviest metals will sink to the bottom, lightest metals will float to the top. And in doing that, they can then separate it out based on the densities of the different liquids that are there. So basically on that, what you're using is you're using physical properties in order to separate that those substances. Number 6, explain the term phase, which is state of matter, as it relates to homo and heterogeneous mixtures. Oh, hold on. Well, we talked about in the notes, we said heterogeneous mixtures are made up of 2 phases. You have solid dissolved in a liquid, and really it stays that way. You have that solid and liquid in there. So heterogeneous mixtures are 2 phases. I did just think, I didn't tell you for homogeneous, what are those? Those ones are all single phase. Even when like in the case of pop, you dissolve sugar in water. Well, that sugar is in there, but it doesn't stay as a solid inside there. It actually becomes, the entire thing is all a liquid. So when that sugar dissolves in there, it becomes one phase or one state of matter. So I know that question, I apologize, I didn't talk about that in notes, but now there's the answer for homogeneous, but hopefully you had at least the heterogeneous part. So I would probably go back and add that one phase piece to my homogeneous notes on hopefully your previous page in your notebook. All right, next question. Question number 7. What do you need to do with a bottle of medicine that says it is a suspension of the antibiotic amoxicillin? We talked about that in the notes. If it says it's a suspension, it's probably going to have the sticker on it that says shake well. So you got to shake it up in order to get that stuff all back into solution. Something else would be like this would be Pepto-Bismol. When you pick Pepto-Bismol up, it all settles to the bottom. You got to shake it up to get it back up into solution. Last one, number 8. Why do laser shows put fog in the air during the show? That's for the Tyndall effect. So we can see that beam of light through the air. If we don't have the fog in the air, all you're going to see is a dot on the wall far away, and you're not going to see that beam. It's going to be a really boring laser light show. All right. Oh, wait, there's more on the back side of my paper. Number 9. Why don't you have to shake a bottle of pop before you drink it? Think about the molecules. Now, really, when you think about the molecules in this is that those molecules that are in there in pop don't settle. They stay dissolved the whole time. So you don't have to shake pop to get it back up like you would if it was the amoxicillin or if it was a glass of muddy water. Why you're drinking muddy water, I don't know, but let's assume you are. Then the mud's all sunk to the bottom. All right, pop, it stays dissolved all the time, so we don't have to shake it. Kool-Aid, once it's made, it stays mixed all the time. You don't have to re-stir up Kool-Aid because it's been sitting in the refrigerator for a long time. It doesn't all of a sudden settle to the bottom and you end up with clear water at the top. Last question, number 10. Describe an event that shows the Tyndall effect. Again, you could have all sorts of things on this. One would be you could talk about a laser light show where they have the fog in the air to show the laser beam going through. You could have said dust in the sunlight. I know I always have sat like on a really sunny day, you can see in your house, there'll be like beams of light coming in the window and you'll see little particles floating around in the air. And when you see those particles, it makes it so you can see that beam. You can even see it sometimes in the sky and you'll see like beams of sunlight. And that means there's particles in the air to make it so that we can see that beam of sunlight. We can look like a laser going through suspension or a colloid like milk or muddy water. And that will show the Tyndall effect. But if I run a laser light through pop, I'm not going to see the beam. So that is not, you're not going to be able to see the Tyndall effect. All right, well, that concludes this set of homework. All right, so we'll see you in the next video. Have a great day. See you.